Question 14, we have two parallel plate capacitors A and B. They have the identical area, so area for capacitor A equal to area for capacitor B. So I denote by A. But the capacitor A is filled with dielectric constant, so capacitor A is filled with dielectric constant. Given the dielectric constant for capacitor A is 6.7 and B is empty. So for B is empty. So empty I understood means it's an A filled capacitors. So both capacitors are connected to the same potential difference. They are connected to the same potential difference. So it means that the voltage across capacitor A is equal to the voltage across the capacitor B. So VA is equal to VB. I denote by V because the potential difference is the same, and I make the center more clearer. So the both capacitors store same amount of charge. What would be the separation distance of parallel plate A in terms of separation distance of parallel plate B? So I will find what is the separation distance for plate A in terms of plate B. So it means that I will find this one. dA will be how much of dB? So this is what we mean by the question. What would be the separation distance of parallel plate A in terms of separation distance of parallel plate B? So where I'm going to start, I will start from the statement. They are connected to the same potential difference and they store same amount of charges. So I might use equation Q equal to CV. So I know that the charge stored in capacitor A is equal to the amount of charge stored in capacitor B. So QA will be CA VB, QB will be CB VB. And since they are connected to the same value of potential difference, so the value of voltage will be cancelled because the value is the same. So we only left with capacitor A will equal to the capacitor B in order to store same amount of charges. So how we find the capacitance for capacitor A is a capacitor with dielectric. So we have epsilon R epsilon naught A over D. This one for capacitor A, so I denote by A subscript A. And the capacitance for parallel plate capacitor with A field, I have epsilon naught A over D. So I put subscript B, indicates that this is called capacitor B. And then, so I can cancel the value of epsilon naught and also the area. Since the area is the same, they have identical area, plus they have identical area, so the area is the same. So the value area also can be cancelled. So I'll be left with epsilon R over dA will be 1 over dB. So epsilon R is the dielectric constant. So the value is 6.7. So I have 6.7 over the separation for capacitor A equal to 1 over separation for capacitor B. So I rearrange, I'll get the separation of capacitor A in terms of D. So the value will be 6.7 dB. So this one will be our answer. The separation of capacitor A is 6.7 times the separation of capacitor B. So I might write it in sentence. So the dA is 6.7 times of separation for capacitor B. So pause and go to test your understanding on learning outcome 2.3. So please attend question 13 and question 8 in the tutorial 2. Then this is the correction for question 13. Make sure you do the corrections for question 13A. Okay, so please submit your work in Google Classroom before 4 February 4 p.m. Thank you class for your focus and attentions. If you have any questions, you might post the questions in the WhatsApp group or you might personally PM teacher